Assalamu alaikum, students. Welcome to another lecture of Slate. This is Khawaja Yasin, and let's study chemistry. Students, the wait is over. We are here for the most important topic of both O and A levels, moles and stoichiometry. Because this is a common notion in the students that they are not able to solve the stoichiometric calculations, be it an O-level students or an A-level students. So stoichiometry is the most important concept or the topic of chemistry. For an O-level student, it's an important part of P1, P2, and P4. And for an A-level student, P1, P2, P3, and P5, and sometimes P4, which is the A-levels chemistry paper, structured questions, but mostly those four components have major chunk of moles and stoichiometry in them. So this is very important to grasp the concept of moles here. So students, let's start moles. Moles, what is moles? Moles is simply amount of a substance. And when we talk about moles, there are four important formulas which most of you find it very easy to understand and remember and solve. Mostly students say or teachers say that there are three formulas, but there are four. Because one of those formulas has been coming in the exams in P1 especially in various years. So the first formula of moles is regarding moles can be represented by the letter N and has the unit MOL is the unit of moles. So the first formula is N equals to number of particles divided by Avogadro's number, Na, which is 6 into 0, 2 into 10 raised to about 23. This number is a constant. It will stay the same for all the values for all the calculations. So we can say that there is another definition of moles, that 1 mole of a substance is when it contains Avogadro number of particles. So 1 mole of a substance is when it contains Avogadro's number of particles. So in chemistry, we don't use the term substance normally, but there is a reason. So substance and particles can be dealt in different ways. We will be solving questions for them. So when we have a substance as an element, we know that element is made up of particles which are called atoms. So in the exam, if they say calculate the number of atoms in particular element, the same relationship would be of substance and particles. Likewise, we have a compound. Which compound? A molecular compound. So that will be made up of molecules. And when we have an ionic compound is made up of formula units. Note that, student, a compound is made up of molecules, and a molecule is further made up of atoms. Likewise, an ionic compound is made up of formula units, and formula units are further made up of ions. So these will be different calculations. For instance, 1 mole of carbon dioxide will have 6 into 10 raised to about 23 molecules of carbon dioxide. But if they ask you about the atoms in 1 mole of carbon dioxide, since carbon dioxide has one carbon and two oxygen atoms. So we are going to multiply this number with 3, and that will be the number of atoms in 1 mole of carbon dioxide. And the same goes with ions and formula units. So this is the first formula of moles. Now, talking about the next formula. Moles equals to the most important one, mass over mr. Mass in grams, mr in gram per mole. This is a very important formula. You can calculate the mass, obviously, but when you are to find the value of unknown, the identity of unknown, the MR calculation will tell you about the identity of unknown. Then we have another formula. N equals to C into V. C is the concentration, and the unit is mole per dm cube, and volume is taken in dm cube. Or if we have a volume in centimeter cube, we divide it by 1000. And last formula for gases is moles equals to volume of gas divided by 24 decimeter cube. So these are three more important formulas of moles. So this is for mass, mostly solids, but mostly gases can also have this formula. Mostly solids. This was solutions or liquids. And this one is for gas. So these are the three formulas of moles. Now, before we solve questions, let's understand what stoichiometry is. Stoichiometry is the relationship between the products and the reactants in a balanced chemical equation. Now, the most important thing regarding this definition is the balanced chemical equation. Our answer would be wrong if we do not have a rightly balanced chemical equation, because only then will you be able to do stoichiometric calculations. So let's quickly talk about an example that we have here, a question from the past papers. 30 centimeter cube of 100 mole per dm cube sodium hydroxide reacted completely with 25 centimeter cube of sulfuric acid in a titration. Calculate the concentration of H2SO4 in mole per dm cube. Now, as I said, you need to know the balanced chemical equation. So there are various steps. If you remember those steps, they will help you a lot. In the P2 papers, you are given the steps already. But when we talk about the P1 papers, there are no steps given to you. You just have to calculate the answer. So it's easier to remember or memorize a few steps. Step number 1. Construct balanced chemical equation. So what do we have here as reactants? We have NaOH and we have H2SO4. This is a simple neutralization reaction. So NaOH plus H2SO4. The answer will be water and a salt. So students, sodium sulfate, it's a formula which most of the students write incorrectly. If you write the formula incorrectly, your balancing would be wrong, your balancing would be wrong, your stoichiometric calculations would be wrong. So let's see what the formula of sodium sulfate would be. So if we have NaSO4, we know that SO4 is -2 and Na is +1. So remember, you must remember the crisscross method, where the 2 would come here and 1 would go there, to balance it off. So the product would be Na2SO4, not NaSO4, because in that case your balancing would be different. So Let's balance the equation. So 2 is here, sulfate is there, sulfate is 1, hydrogen 1, and what 2 moles of water. So this is the balanced chemical equation. Now, step 2, find moles of the standard, and there's another term that we use for standard, known. Now, which solution is known to us? We know about NaOH, we know its volume, we know its concentration. And with this, can we calculate the moles? We can calculate the moles using this formula. And what about this formula? This is sulfuric acid. We just have the volume. We don't have the concentration. And they ask us to calculate the concentration. So our standard is NaOH. So we're going to calculate the moles of NaOH, C into V. This is the next question that we may discuss today. So concentration. Concentration of NaOH is zero point 0.1 mole per dm cube, and into volume. Volume is 30 centimeter cube, 30.0. So now the volume is in centimeter cube, so we're going to divide that by 1000 to convert it into decimeter cube. So this becomes zero point 0.1 into 0.03. 0.003 moles. So these are the moles of sodium hydroxide. Now, step 3. Now, this is the most important step for any molar calculation. Construct a molar ratio. Now, what is a molar ratio? Molar ratio is the ratio between a known and an unknown value. The known value that we have is NaOH ratio, unknown value, which is the H2SO4. So we need to, now that is where the balanced chemical equation plays an important part. Moles from the equation. NaOH, how many moles of NaOH do we have? 2. And moles for H2SO4? It's 1. So these are the moles from the equation. Now calculated moles or moles from the question. We have the moles of NaOH here. This is 0.003. Now what you're going to do, just like a ratio method, you're going to cross multiply both the values. This becomes 2x equals to 0.03 into 1. So x equals to 0.003 divided by 2. And the answer becomes 0.0015 moles. Since you have calculated from one value of moles, the other answer will also be in moles. So this is the moles of H2SO4. Now you have calculated the moles of unknown using the molar ratio, which is the step 3. Now talking about the step 4, where we are going to conclude the question. Step 4. Find the value using a relevant formula. Now, relevant formula. What do they want us to know? They want us to calculate the concentration. We have the volume of H2SO4. We're going to use the relevant formula, which is again N equals to C into V. So again, we have the value of moles, which is 0.0015. We don't have the concentration. We have the volume, which is 25 divided by 1000. We're going to cross multiply the values. The concentration equals to 0.0015 multiplied by 1000 divided by 25. So the answer is 0.06 mole per dm cube. So that is the answer, students. And that is how, with these steps, we have calculated the amount, the unknown value, which is the concentration of sulfuric acid. This is a basic question. Let's do a different question, a difficult question. An acid has the formula of H2XO4. Okay, I know you can understand H2XO4. What does X stand for? But let's calculate and solve it. 1 mole of H2XO4 reacts with 2 moles of NaOH. A solution of acid contains 5 gram per dm cube of H2XO4. In titration, 25 centimeter cube of acid reacted with 25.5 centimeter cube of 0.1 mole per dm cube sodium hydroxide. Calculate the concentration of acid in mole per dm cube and find X of the acid and its identity. So, students, this is a different question. Step one, can we make the balanced chemical equation? So, since we have H2XO4, we know nothing about this acid. So, we cannot, when there is something unknown in the question, you will not make a balanced chemical equation. So, how can we calculate the molar ratio? Because in the above question, in the previous question, we used the equation for the molar ratio values. So let's see. Start solving the question. But before that, which one is the standard? Which one is the unknown? We know that we have the volume and the concentration of NaOH. So NaOH is again the standard here. So let's quickly calculate the moles of NaOH using the same formula of N equals to C into V. So concentration. We have the concentration which is 0.1 mole per dm cube, and we multiply it by volume, which is divided by 1000. And the answer will be 0.00255 moles. So students, we have the moles. We know the molar ratio that we have to calculate or find. So molar ratio will be between NaOH and H2XO4. So now we know, so at first we need to know the normal moles. In the second statement, it says 1 mole of H2XO4 reacts with 2 moles of NaOH. That is what the information that we can get from the balanced chemical equation. So we know that 1 mole of H2XO4 and 2 moles of NaOH. Now let's use the moles of NaOH from the question and we cross multiply the values. So the moles of H2XO4 are 0.001275. I just cross multiply both the values. So these are the moles of H2XO4. But they've asked us about something, calculate the concentration of acid in mole per dm cube. Can we? We definitely can. How? N equals to C into V. We have 0.001275 given. Concentration is something we don't have, but the volume is definitely given to us. 25 centimeter cube of acid reacted with it. So 25 divided by 1000. So concentration equals to 0.001275 into 1000, and we divide it by 25. And the answer becomes 0.051 mole per dm cube. So students, now they want us to calculate the identity of X. I will tell you a shortcut formula as well, but let's understand the concepts. We have the acid contains 5 gram per dm cube of H2XO4. 5 grams per dm cube. So this is a relationship. Let's keep this aside. Let's understand the relationship between mole versus mole per dm cube. So what did we see here? The value given here, these are the moles, just moles, but in which volume? Moles in 25 centimeter cube. And this value is the moles in a dm cube. So for instance, I have 1 decimeter cube, which is almost 1 liter. So I have 1 liter of a solution. I just transferred 25 centimeter cube from that. So this is just a correlationship between the two. The above moles are in 25 centimeter cube, and this is the moles in 1 decimeter cube. So concentration is also moles in 1 decimeter cube. Moles are just moles in any particular volume. but concentration are the moles in 1 decimeter cube. So let's say if the solution is 1 decimeter cube, so we have 5 gram per dm cube and we have 0.051 mole per dm cube. There is only one formula. Obviously, gram and mole are at play. Both the dm cubes will be cancelled out because obviously the solution is 1 decimeter cube. So there is only one formula which deals with both gram and moles, which is N equals to mass over mr. So students, using that formula, we can calculate the mr of the unknown acid. Moles that we have, moles are 0.051 and mass is 5 and mr is unknown. So we rearrange it, 5 divided by 0.051. The answer is 98. So mr of the acid is 98. We don't know about the x. We have just calculated the mr of the acid. Okay, I know this actual way tends to be very confusing for the students. So in case you have a value in gram per dm cube, in case you have the value, so just forget the concept. Let me give you a formula which you can always use. So mole per dm cube equals to gram per dm cube divided by mr. So in case you still have difficulty understanding this concept, just incorporate the value, incorporate this formula. So as you can see, mole per dm cube value, which is 0.051, it's here. Gram per dm cube value, which is 5, it's incorporated here. So that is how we calculated the mr. Students, this is a very important question. It has many concepts. So now let's see how can we calculate the value of x from the mr value. So we have H2XO4 and the mr of H2XO4 is 98. So let's calculate the value of x here. Simple calculation. We know that the AR of hydrogen is 1 plus x. We don't know about x. Plus 16 into 4 for oxygen equals to 98. So 2 plus x plus 64 is 98. So x plus 66 is 98. So we just do the simple mathematics. 98 minus 66, we're left with 32. So x equals to 32. We open the periodic table. We see that there is only one element whose AR is 32, and that's sulfur. So the compound becomes, as we knew it from the beginning, H2SO4 sulfuric acid. So student, this was a very important concept when we talk about moles. In this particular question, we dealt with gram per dm cube, we dealt with the value of unknown, and again, molar ratio is obviously there. So these are the two important questions. I would want you to go through these questions again, try to solve these questions. In the next videos, we will solve such questions again because I know the gram per dm cube conversion is a trickier one. We will be dealing with, I guess, at least it's a promise, we will deal with 2 more questions. So thank you so much for being here with me. Thank you so much. I hope this video was helpful for you. We will be coming up with more molar calculations, more videos regarding moles. Allah Hafiz. Goodbye.